Hi, everyone. Welcome to this afternoon's webinar on Data Fabric, the next step in the evolution of data architectures. I'm Saurabh. I am the production manager with Eckerson Group. I'm here with our research analyst, Jay Piscioneri, and Saket Saurabh from Nexla. So we're going to have a wonderful chat today. Just a little bit of housekeeping. I know everyone always wants to know if there's going to be a recording available after the webinar. And yes, we will be sending a follow-up email to you with a link to the recording in it. And also, please use the Q&A button at the bottom of your screen to ask your questions, and Jay and Saket will answer those for you. You may also see some of the other Nexla team members may type out an answer to you, but we ask that you use the Q&A button. And I think we're good to get started. Jay, did you want to take it away?
Sure. All right, well, welcome everybody. And Saket, great to be here with you. We're going to talk about data fabric, so let's just dive in, and we'll start with talking about the evolution of data architectures, which will begin with data warehouse. So with the data warehouse, this was an architecture that was came to the fore in the 80s. It's optimized for business intelligence workloads, and it's a pretty familiar structure to most people today. It's centralized storage, a standardized data format, centralized management, and preparation by a centralized data team. So this worked well for a while, but and it still fits a niche, but it does not keep up with the volume and velocity of the modern data environment. So next in the evolution, we saw the introduction of the data lake, and this was really optimized for data science workloads. Like the data warehouse, it's based on centralized storage, bringing all the data together in one place and managing the data centralized. But it differs from the warehouse in that it encompasses many data formats, and also, as opposed to doing ETL, where the centralized data team does all the preparation and transformation, preparation is done by the data consumers themselves, which is the ELT format. So the data is in the data lake in its raw form, and then each data consumer can prepare that data for whatever their purpose is, whether it's a machine learning algorithm or some other process that may be feeding data to an application. Then along comes data fabric, and really what data fabric is trying to do is encompass both of these needs, which are prepared data for data consumers that don't have the skill to do their own transformations, and as well as having data in its raw form for data science applications. But also, the data fabric is really the other thing it brings is automation for data preparation, automated data management, which we'll talk about a little bit more in some more detail. And also, the data fabric is not just a structure for analytical data use cases. It also has applications for operational data management. So let's look at what data fabric is exactly. So it's an architectural approach that uses metadata, machine learning, and automation, and it brings together data from in any format, from any location. And the intention is to make it easy to find or use for both people and systems. So the other thing is that as I said, it automates data management functions, because keeping up with the modern data environment using manual integration and cataloging, et cetera, is just not viable anymore. So it brings automation through the use of metadata to integration, which is connecting to data sources, preparation, which is transformation, cleaning, applying algorithms, cataloging, which is tagging and defining, providing business definitions, access management, which is in today's terms really attribute-based access management, which is allowing the data to be dynamically provisioned based on who's asking for it and what the data is. And finally, discovery, which is what makes all the data that's in the environment available to consumers, making it findable through browsing and searching and natural language search and other methods. What lives, here we have a poll. So let's take a moment here, and if you could answer this poll about what is your view of data fabric. You know, what's your orientation toward it, and what are the biggest challenges? So I'll let you guys work on that poll, and but meanwhile, going back to kind of getting into what are the components of data fabric. A data fabric sits between the source systems and data consumers. It's got several processing layers. We talked about connectivity, abstraction, which is the process that hides the complexity of the underlying source data systems. And we'll talk about that in a little bit more detail in a moment. Retrieval, which is bringing the data back either as a virtual object or a persisted object. That depends on what your needs are. And then access management, as we mentioned, which is provisioning data according to role and attribute-based access controls. Then there's also a application functionality that enables people to interact with the data in the fabric. And that, as we talked about in the previous slide, consists of discovery, which is making it possible for people to find data and understand what a given data set consists of. Preparation, which is bringing together different sets of data, formatting it, applying a structure, cleansing, cataloging, which is labeling and classifying and tagging, particularly important to automate these functions, because the automated tagging and classification of data feeds into other aspects like access management. So being able to identify PII attributes automatically is something that helps you manage data better at scale. So all of this sits on what I could think of as a sea of metadata. And to me, if the metadata is like the foundation of the fabric, using metadata to coordinate interaction between these different functions through the use of AI and machine learning is what really makes the data fabric approach most effective for where data has evolved today. So next, let's take a look at the concept of abstraction, because I don't think you can really overstate how important abstraction is to data fabric. So in your environment, you've got multiple sources. You've got on-prem data, you've got data in various clouds, you've got it in different formats as databases or files and system logs, you've got streaming data, data from other applications. All of this makes, if you try to interact with these data sources directly and stitch it together, it's extremely onerous and time consuming. And this is specifically what the abstraction layer in Fabric is trying to solve that problem of complexity and hide the location and the format details to deliver objects that we call abstracted data objects. And these can be either virtual or physical objects. The Fabric doesn't, the Fabric concept doesn't take a stand on whether they should be one or the other. In fact, in my opinion, you should, use virtual when you can, but physical when you have to. So this initial abstraction of the data sources then leads to the ability to compose those different abstracted objects into derived views. So for example, if you want to get all your purchases from different sources into one view, you would start with the abstracted objects of the underlying source systems, and then do the preparation of combining and aggregating and filtering and cleansing to create an all-up view of purchases. Similarly, if you want to have a special data set that is, for example, identifies customers that are going to churn, bringing in data from different sources and then applying the appropriate algorithms to perhaps calculate a churn score, then gives you this ability to apply sophisticated analysis to the data without having to worry about where the data is coming from or what format it's in. So that's a quick overview of the data fabric and its key components and some of its more important concepts. So let me now pass it over to Saket, and he can discuss how Nexla helps enterprises realize a data fabric in their environment through automation. So Saket, take it away.
Thank you, Jay. Appreciate you giving such a nice introduction to the data fabric concept. What I would perhaps like to start with is sharing a little bit about how some of this comes into practice. And before we do that, a quick introduction about myself and Nexla. My name is Saket. I'm co-founder and CEO at Nexla. And a little bit about Nexla and what we do as a company. Nexla is headquartered in San Mateo, California, and we have been on the mission of making data ready to use for every data user. And when we think about making data ready to use, the concept of the abstracted data object is comes into play very nicely, because what it does is it simplifies how you think about data and not have to worry about the underlying complexities of it. Now, how do we go about this mission? We go about this mission by enabling automation and collaboration for data engineering, because after all, data engineering is the key function that makes data ready to use for the different users. I'm sharing here an example of some of the customers of Nexla that use us today for this very purpose and objective. Okay. Having started in 2016 with this mission, we were one of the early innovators in the concept of data fabric. And this is this was recognized about 2 years ago when we were recognized as a cool vendor, and for specifically this continuous intelligence layer built on data fabric principles. So this was, I want to go into further detail about what that means for a data user, but just wanted to share how Nexla has been operating and working and innovating in this particular concept and approach for the last few years. Let's take a look from a more sort of practical day-to-day perspective, right? The data tasks that we know as practitioners are well understood. We have to integrate data, we have to prepare data, we have to have data quality, we have to monitor data, and so on. Now, these tasks, I would argue, have not really changed in decades, to be honest, right? Now, what data fabric is doing is actually changing how these tasks are done. And this is where we believe that data fabric is bringing automation into these tasks. Now, automation into these tasks means basically how can these tasks like integration of data or discovery of data or quality of data be achieved in an automated fashion where the user has to do fewer inputs and configurations. It's easier to set up, but more importantly, it is also easier to maintain, more reliable, more scalable, and therefore allows us, as practitioners to manage the increasing variety, complexity, and applications of data. Okay. Let me share a few high-level ideas of how data fabric comes to play in some of these areas. One of the key ways in which data fabric comes in, as I mentioned about accelerating this automation, is in different aspects of data engineering. For example, when we start to look at metadata in form of credentials or rate limits or API documentations and so on, it allows us to help generate connectors. I think I saw one of the poll questions earlier, not the poll questions, audience questions actually earlier, about how large language models would apply to the data fabric concept. And I think this sort of illustrates that well, is application of those generative AI technologies can actually help us generate things which otherwise would have to write code for. Okay. The other aspect, for example, that we'll actually double click into today is how understanding data at a sample level, understanding a schema, understanding what logic makes sense, and so on, helps us to create this concept of logical data products, which I would think that is the concept of abstracted data objects, as you shared earlier. I'd love to see if I'm off on that aspect, Jay, in how you see it and how we might interpret it as we go further along in the conversation.
Yeah.
Okay. What else can we look at? I mean, things like anomalies in data, past error events, error codes, other data characteristics can help us improve monitoring, again, in an automated fashion. So this is, again, application of metadata, applying intelligence to that metadata and helping us, ensure the quality of data more easily. The other piece is also scaling up pipelines. When we build up a data pipeline to process, say 100 million records, and at some point it becomes a billion records or 10 billion, scaling those things is not as straightforward. Creating parallelization and managing that can be complex. So again, we'll look at specifically in more detail, how data fabric concepts apply to scaling a pipeline. Okay, so these are the two things that I'll go into more details as we go into the data fabric conversation with some of these practical examples. And again, welcome questions as we go along. Okay, so before we do that, why don't we take a little bit of a look at metadata? And the reason I want to do that is metadata is all over the place. It's everywhere. We have traditionally thought that metadata only comes from database systems where you can have query logs and you can have data schemas and so on that you can get from the database. I'll argue that metadata is available everywhere, even when we look at spreadsheets. So on the left-hand side, it's a very simple example data spreadsheet where you have, ID, first name, last name, and email, right? And what is the metadata that we can see here? We, of course, can infer the schema of the data by scanning through it and looking at, this field looks like an email ID because of its characteristics and how it is structured. We can see how much data is coming in. In this case, we have, a few hundred records coming in. When does this data arrive? Now, this is not inside the file, but outside the structure, you have access to that information. So this data comes at 4 p.m. and it has a certain file name to it. And when we process this data, how long, what does it involve? What does the pipeline perform like? How long does it take to ingest this data? How long does it take to apply the necessary transformations that we wanted to it? How long does it take to maybe move the data to a different system? So these are things that we can see, for example, on the left-hand side. On the right-hand side, it's a different file, and it comes a couple of weeks later, perhaps in the same location, different amount of data, but now the schema is slightly different. We have a phone number also available here. So now we have metadata of how the schema has updated, how the amount of data has varied, how the arrival time of data has changed, how the names have modified and so on. So there is a lot to actually infer from, a seemingly, simple spreadsheet, if you will, in terms of what metadata can be extracted from here. Okay. So hopefully this gives a good idea about, just where all metadata can be available and both explicitly or inferred, like, for example, pipeline performance. I'll give you an example of how we take advantage of this sort of metadata. And in this screen, you see here how the schema ID has actually changed and the system has detected that the schema has updated. And the schema has updated by adding a new attribute to that schema and understanding that data has actually evolved from its regular structure to a new format, and present this to the user. So these are some examples, I would say, of taking metadata, applying intelligence to it, and then taking advantage of that with the data fabric approach. What do you think, Jay? Any questions on this?
Yeah, I mean, I'm very interested to see. Do you have examples of how this translates into practice, right? How customers are actually using this capability?
Yeah, I think I would love to share that and share a few examples. And I think one of the things I shared was this concept of auto scaling pipelines. And I think it's a fascinating data engineering problem when we deal with variations in data volume and have to really handle some of these challenges. So let me take an example from some of our customers and in how we see this happen. Okay. So here I'm going to take an example and apologize for the broad slide with a bunch of things happening here. I'll point them one by one. So this is an example that we see very commonly. Nexla is used by several delivery companies like DoorDash, Instacart, Glovo, and so on. And one of the things that happens, the reason I use this example is very easy to relate to. We've all used some sort of delivery services, right? And we go to an app and we look at what's available and we make a shopping list out of that and just, things get delivered to us. So what is happening in the background is clearly that, these companies are relying on data to make their services available. So for example, when they're delivering from the different stores that we are familiar with, like CVS or Walgreens or Safeway and so on, they receive a significant amount of data from these providers. This data is what allows them to understand what products are available in which store. And again, we know that different stores of the same merchant have different sets of products available, and even availability can vary from day to day during the course of their daily business. So what happens in here is that the way the data fabric architecture applies is the system connects to these data feeds, which can come in different ways. They can come in APIs, they can come in form of files. And what it does is it tries to understand and structure what's coming through that feed into an abstracted data object. At Nexla, we call it an Excel. And the approach here is that this abstraction is now making it easier for the data user, the catalog analyst or the account manager, for example, to understand the data. Because, whether it was a JSON feed coming to an API or a flat file in CSV coming via FTP, the data users actually understand the data quite well. What products are sold by units or weight, how does a coupon apply, what items are taxed and so on. So what they are able to then do is use, some of the no-code tools, for example, which you provide to then create sort of user-defined structures, which are sort of canonical representations. Because if you are, a delivery company, you don't want to deal with different data structures, different schemas coming from everywhere. You want to unify that into a single sort of structure so that your application, your logistics application or e-commerce application can consume that data and then create your downstream applications and services, right? So this is a very common case of, processing data, ingesting it, moving it to the right place and making it available to the user of data. In this case, ultimate user of data is a logistics application or an e-commerce application, right? Now, how does scale come into picture? So there are a bunch of processing constraints that we can expect in some of these scenarios. So for example, data volume by a merchant, as a merchant onboards in one of these services grows sort of rather rapidly. So it could go from a few hundred stores to thousands of stores. And just for the audience's context, there are over 10,000 CVS locations in the country, right? So you can imagine the amount of data that it would involve, especially because stores themselves have thousands of SKUs. Now, data can come in multiple times in a day because we have seen that certain items may go in and out of stock, and then there's a sort of tight timeline to process this. The between often between store closing and opening the next day, or even during the day, you want, and as soon as fresh data is available, and that the inventory level for this particular product have gone down, you want to update that. So you're not having people order items that are not available, or going and dispatching someone to pick up items that are not in store anymore. So there's a tight time window. So your processing time is tight. You have to get it done, let's say, in 2 hours. And the data volume keeps increasing from a few million to a few hundred million to billions of records. So one of the ways in which the data fabric architecture sort of surfaces itself in this case is something called a speed factor. So what is presented to the user is the concept of a speed factor, which is once you have designed the data flow and all the rules and processing with it, you can choose how much is the maximum speed you want it to run at. Okay. Now this itself then translates into underlying actions that will make the data, run within that sort of speed, that sort of scale is being applied to processing. So let me double click on how that happens, right? So there are different stages of processing data in this case. I mean, the data is being ingested, data is being output to some systems, data is also being transformed. And the way the system works is that, as it starts to ingest data and, looks at how long it's taking for the data to then flow through the transformations, the delivery, and when does it hit the target system, based on that, it's able to understand where the bottlenecks are. Is data processing taking longer because there are some complex joins and transforms happening to the data, like inventory feed, is being combined with product details, descriptions, images, and so on. So based on this, based on the performance of each system, some systems can accept data very rapidly. For example, if the data is being pushed to an API, it is possible that there are rate limits. And based on that, you have to slow down, in some cases, right? So the data fabric sort of approach is to instrument each section of the data processing, understand where time is being consumed, understand which services can be scaled by throwing more compute at it or more streams and so on, and automatically sort of configure those to get to the necessary goal that the user is looking at. Now contrast this with taking a pipeline that you have and trying to run it 4 times faster, and all the additional code that it would involve to make that happen. So this is how applying that metadata from data processing comes into play. So hopefully that shares a little bit about a practical application, right?
Yeah, and that's a great example because that the challenge of scaling is one that always creeps up much faster than you expect, right? So knowing that you've got a way to deal with it in your back pocket is really great. I wanted to ask about Nexets, right, which is kind of your idea of a data product, and how data products, which we don't normally associate with the Fabric buzzword, right? How do data products fit in with data fabric?
Yeah, that's a great question. I think in technology, we always keep coming up with new keywords, and then we start debating them and creating all these expectations from it. Mm-hmm. But I think that oftentimes they relate with each other in different approaches. For example, when we think about data fabric and we're using metadata, I think that it helps in creation of the data product concept. So let me go and double click on that. And I think it's important to even understand what we mean by data products before we go there, right? So, we covered the concept of, abstracted objects, the things that we want to do with data, and how metadata intelligence brings automation to the tasks that we want to do with data. So let's take a look into, how the data products come into play. So we believe that this metadata intelligence, which we are looking at all this metadata, everything that we can capture from the data system, from the data processing. At every single stage, we're capturing so much information. This information can actually help us deliver a data product like entity, which I think relates very closely with how you've talked about the ADOs or the abstracted data objects. But we add a little bit of a layer to that where now users can also interact with them, and we come up with this concept of what we think as user-defined data objects, and they start to look like data products. So let me, before I go further, let me maybe just break down for everybody like what is a data product in the first place, because I think there is plenty of confusion out there about, I put the data in a table, isn't that a data product? Or I wrote a query, is that a data product? Or I have a visualization on a dashboard, is that a data product, right? So I think, maybe let's take a look at that first, okay? I'm going to try and draw a parallel or explain what a data product is by just looking at what a product is in the first place. So I'll draw your attention to the left side of the screen where let's think about what is a product in the first place. I mean, a common product that I think we all are familiar with is, shoes. A product that we understand usually is made from raw materials, right? A shoe is made from fabric and leather and synthetic materials, right? But a product is a finished product, which means that I can go take this product and apply it to a particular purpose. For example, the shoes could be for running or biking or basketball or whatever is your purpose, right? So you're looking for a product that meets your purpose, has the right sort of styling and design, fit, and all that stuff, right? Now, products are typically created by producers. Somebody has gone and created that data product, the product, for example, in this case, shoes, and now it becomes available to consumers who can go find that product and use it. And these products have a standard interface to it. Like shoes has a pretty standard interface. We all know how to use them, and we can all go online or in a store and find and get it, right? So this is how we think about products in our day-to-day life. So let's take that parallel into how we should and we could think about data products. So when we think about data products, I would say that, again, like any product, it is built from raw materials. Now, one thing that we often confuse is we think that data is a data product. So rows and columns, for example, as I showed in a previous slide, we think that is just the data. That's the raw data. That alone doesn't become a data product. Other raw materials go into making the data product. For example, metadata. For example, validation rules. For example, documentation, just describing what a particular attribute is or how it behaves. For example, is user contributed metadata. And this is, again, one of the areas where we do think that large language models and generative AI can have a role to play, where sometimes even documentation can be inferred and generated in a reasonable fashion for certain things, right? So these are different things that go in as raw material. And what is the finished product? The finished product is something that is documented, that is validated, that is trusted, it has access control, it has governance, it can be searched, it can be found, and can be used, right? So if I say that, you are a business user and I'm going to give you an API, that may not be the data product you are, looking for. For example, you're looking for something that you could use in your own way, in your own tools, which sort of, refers to something that is accessible and usable by you, right? So what is the concept of the data product is to make that possible, make it possible for people to get that finished product, not something that is in its raw form. One of the concepts of the data product, we believe, is also that it can be self-serve. Unlike, products like in the physical world that we know, we can sometimes take data products and, create our own derivatives from that, which is the benefit of, a software product. And, data products, just like any product has a standard interface, have the concept of a data contract. So if I get a data product, I expect it to have a certain reliability or a certain quality, have a certain schema to it, not have, incorrect data, for example, and so on. So that also sort of comes as part of that. And then it could be used for different purposes. So we think that this is, one of the ways to look at data product and not sort of confuse a data product with data or with metadata or with documentation or with a query, for example. Okay. And in fact, I think that data fabric really has an important role to play because the abstracted data objects actually lead to the concept of a logical data product, where a logical data product means that you have one interface to any data, easy for a user. if they don't have to understand the underlying complexities of the data system. It also helps abstract the design from execution. So once you have a data product, you don't have to, it can be used in different ways. For example, you could technically move these logical data products in across clouds, or you can access them in different ways, like through an API or a spreadsheet, for example. And then, the product concept helps collaboration to also become possible through this producer and consumer approach. Okay. So hopefully that gives a good sort of light on how data product leads to the data fabric approach leads to a data product construct, and that data fabric and data mesh are not necessarily competing. In fact, data fabric can create the data products, and the data products become a component of the broader mesh sort of framework. Okay.
Yeah, I think it'd be great to expand on that because initially data mesh and data fabric were kind of seen as competing concepts. And I believe that my sense is that people are beginning to see that there's a fair amount of overlap and synergy. What's Nexla's take on that?
Yeah, I think the confusion around the two is sort of natural because of the wording. When we say something is a fabric and something is a mesh, and we of course understand that fabric in sort of day-to-day common parlance is a mesh of threads, then it sounds like they might be something similar, right? Mm-hmm. And clearly both these concepts or approaches picked up momentum in roughly the same time frame. So and again, as practitioners, we are bombarded with so much sort of terminology and jargon and different vendors and sharing that with us and creating that confusion. So I think it sort of starts from that, and but I think they actually are interrelated, where the data fabric sort of creates or can help create an entity that can then become a data product, which can then help into the mesh. So I think that's why when you started and saying this is an architectural approach, sort of makes sense to me. Whereas a data mesh, to some extent, is partly process and practice and framework, similar to how I understand, for example, agile software development, has a certain process and approach to it, but that doesn't separate it from the fact that you still have tools that help you achieve that, agile development process, right? And in a similar way, I think about data fabric as one of the tools or components that will lend itself to a full data mesh implementation. Okay.
I mean, certainly data fabric and data mesh have in common the need to simplify the underlying complexity of the environments that are creating the raw material, right? So
yeah. Let me try and maybe bring this all together into one place. It sort of puts the picture in one slide for everybody here. So the way to think about it step by step is, there are so many data systems out there with different formats, structures, and velocities. Applying the data fabric approach leads us to sort of create these abstracted data objects. And then different user actions on these abstracted data objects can lead to user-defined data entities. And then these user-defined entities can be used in different ways. For example, they can be discovered, they can be used to output data in different places, they can be collaborated upon, you can have ratings, comments, and stuff like that. And when we look at each of these entities and we try to use it, the different users of data want to use a particular entity, it can eventually materialize the data in different places. So now you have gone the full cycle of bringing the data to the user in the tool that they are familiar with, in a structure that makes sense for them, and going through all this sort of processing from one or more systems where it becomes to ultimate use. And that's what we're trying to do. We are all trying to make sure that in this world, as everybody becomes a data user, they can get the data in their hands and they can get it faster and easier, and they don't have to worry about all the underlying complexities, because we really have to move beyond all the time and effort it goes into making data usable, right? And in every single stage, and as we look at this, we think that this applies to all sorts of data processing, whether it's real-time, batch, or streaming, or in hybrid or cloud or SaaS environments, right? So The Fabric sort of concept applies at every stage, whether we are generating connectors by understanding the underlying structure of connectors, the credentials, documentation, and so on, whether we're applying metadata intelligence to package into abstracted data objects, whether the data fabric is creating recommendations. What can you do with this data? How can you make this data usable? Or how does this data object sort of relate to or combine with the other data object, for example? And then, when it comes to using the data, how this applies to eventually materializing information. Should this data processing happen in real time, or should this happen in a batch mode? These things can be interpreted by applying a certain set of intelligent approaches, I would say, to information that's already out there, or sometimes it is suggested by the user. So all of these things together, I think, can bring greater speed and execution, right? And I think that this picture sort of connects some of those dots together. One of the things that you also mentioned, Jay, earlier was the discovery of stuff. And this is something that we have seen as the different approaches to it. But one of the approaches that is happening in some of the organizations is to build this internal marketplace. So take some of these selected data objects and elevate them to the level of a data product, have a full process around it, sort of assure their quality, their reliability rating, and so on, and make it possible for more people to be able to discover and find and get access to that data. Now, the reason this becomes extremely powerful, I think, is that this relates back to a very long long-term goal of the data community is around democratization. Mm-hmm. And the way I think that this all comes together in a way is that on one hand, you have automation, which is the data fabric approach, that helps things happen in an automated fashion without people having to be that technical or having to write code, for example. And on the other hand, it enables collaboration because the concept of these data entities really allows for a common entity that people can come together and work together on. So I think hopefully this sort of makes sense and ties together the entire story.
Yeah, it does. And I think one of the important things here is, when you talk about the marketplace, right, and democratization, to use your analogy of the shoes, right, a pair of running shoes is created to deliver value to a particular customer who wants who's a runner, right? Well, a pair of running shoes sitting in a shipping container does not deliver value, right? The user can't find it, they can't try it on, they can't compare it to other products. So the marketplace, I think, is an important, or marketplace functionality, if not an actual application. That ability to create, to allow the consumers to find and compare and understand what a data set is about is really critical. And I think that's part of the definition of a data product, what separates it from, a spreadsheet that somebody put together for their own use, for example. But with all of this, it all starts at connecting to the source data. So what are your thoughts about that and how that can be made easier for practitioners?
Yeah, I think connecting to source data is actually one of the underestimated challenges, if you will, because we still talk about connectors, for example, in our ecosystem as to how we have tools with hundreds of connectors, but hundreds of connectors actually is a very small number when you look at enterprises and their complexity and their breadth and if we have time, I'm happy to go sort of look into this as well and share how the data fabric approach leads to a possibility where some of these connectors can be generated rather than programmed by vendors, and thus creating a limitation for companies or users is like, I'm waiting on the vendor to support a connector because the particular CRM system that I'm using or the legacy mainframe that I have or the homegrown application that I built do not have a connector. And but they still have valuable data that I would like to take advantage of. So do we have a few minutes to go into that, or do we have questions that we should address first?
Let's see. So I think we've got most of the questions that came up in the chat have been answered. Mm-hmm. So yeah, let's dive in.
Yeah, I'm looking at some of the questions, and I think there's a question about data catalog. So yeah, let's take a couple of minutes to quickly cover the concept of the connector, and then let's cover some of these more questions as they're popping in.
Sure.
Encourage people to write in more questions, and I think we have time to cover all of them.
Yeah.
The ones that have not been touched upon yet. At a very high level, I mean, the way we understand connectors are that, we have a source and somebody writes code, and we have, credentials and all the business requirements, and ultimately from that is what we generate a connector. Sorry, I accidentally clicked through my screen here. That's how connectors get generated. But the challenge with this, of course, becomes that you have to regularly update the connector. As the specification for that API changes, for example, connectors have to be created, which makes them error prone, of course. The other point is that, how much engineering can be applied given the variety of systems, and given that there are even systems that are homegrown and not standard, right? So connectors are therefore kind of challenging to sort of keep up with. So the approach from the data fabric perspective is, how can we take information such as, credentials, or for example, certain pieces of information, the documentation, and then leverage that, perhaps with some configuration to then generate connectors. And I think the sort of powerful thing that can happen here is also that when we think about connectors, we think about data connectors that are reading data. We should also realize that these connectors also are the source of metadata. So to make a data fabric architecture possible, to have access to that metadata, is extremely important that these connectors, for example, are not just reading a file and getting the rows and columns, they're also getting the other metadata associated with that. Or they're not just calling an API, they're also telling us, how it's performing, and what errors we're getting, what is the rate limit, and so on, right? So there's a lot of metadata to be captured by the connectors to be brought in to the data fabric core to leverage. So that's the other part of the connector aspect. So when we approach it in that way, we say that, hey, these connectors are not just data connectors that are reading data, they're actually reading metadata. They're actually also able to write data back to a system, because even that is sort of valuable. And then, this all sort of creates this concept of generating connectors, making it possible for people to have any data system of their choice and have the system create a connector, or maybe, it takes a few user prompts or some questions at best, but that's kind of the ideal approach. And I think in many ways, the data fabric approach is sort of, bringing that. At Nexla, we have been extremely successful in generating connectors to a lot of legacy or homegrown systems with some of the large enterprises, as you can imagine, because they can't just go and adopt every new tool out there. They still have to support a whole bunch of legacy and, applications. So that has certainly been a powerful capability from having, at least for us, having built from a data fabric architecture. I think ultimately what this has done, when you can generate that connector automatically, and when that connector can lead to an abstracted data object, and that data object can actually be a common interface to data, it sort of becomes possible to create a sort of a collaborative and a self-serve approach. So now many of these things are happening automatically. The users of data are able to do most of the things on their own. And then, a well-designed system is still allowing engineers to come in and do more complex things. So hopefully that gives a bit of color into how connectors have an important role in playing in making the data fabric possible in the first place, and how the data fabric in turn can help scale up connectors.
Yeah, very interesting. So there are a number of questions here, and I guess I misinterpreted. They have not been answered. They've been acknowledged. So I think if we just want to go in and into the question and answer list here and pick off a couple to take on, there are some interesting ones. For example, Paul asks, is it common that many data sources lack metadata as a deliberate practice, or any version control, plus certain patterns like event sourcing are more congenial for reconstructing historical or causal views? So Yeah, I mean, I guess we're getting into details now about different processing requirements and patterns. What's your take on that, Saket?
Yeah, I think the challenge with data sources is certainly that some of them have just been around for a long time, right? I mean, but just think of how you'd be surprised, Jay, if I shared with you how much data actually goes around on FTP servers, right? And this is a standard from several decades ago. So oftentimes data systems were not even designed for metadata. And but there is a lot of metadata that can be inferred. Again, I think we should not underestimate what all we can glean from the little bit of information that we have. This and also this sort of information that you see on a regular basis, just even with an FTP server, if files are showing up every day at 4 p.m. and they have a certain structure to it, and there's a certain amount of data, you can infer a lot from that in terms of, hey, is there more data coming? Is there less data coming? Is there an error in the data and stuff like that? So there's a lot that can be done. But I do see Paul's question that, our data sources deliberately lacking metadata. I think, as for example, as databases have moved into the cloud and are offered by infrastructure providers, sometimes they don't open up the metadata, which otherwise that particular database system underlying does create that. I think it's important for people to open that up and make that metadata accessible, because I think it allows for simplicity for the data user and ultimately enables everybody to just use more data, and I would say benefits the entire ecosystem. So, yeah, I would say that if more systems offered metadata and made it open, for example, in our case, we open up all the metadata that we capture or we see in our system in JSON format for consumption for our users. I think it would make so many applications interoperable. So, your scheduler could be easily interoperable with your catalog, could be maybe interoperable with your pipeline. And, and all of that would lead to, I think, more higher order decisions in the process.
Yeah. Yeah, I think that's a critical point there, is that, like I said in the beginning when I was introducing fabric subject, is like, to me, the threads of the fabric are metadata, right? That's what ties it all together. And the more of it you have and the better it is, the more of that interoperability you can create, which is really how you scale all of this, right? So I think that's a great point. George asked about, does this include a data catalog, or how does it align with existing data catalogs? And I think that brings up a really good point, because data fabric is parachuting into existing environments, which have lots of stuff already in place, right? So how does that work in practice?
Yeah, from what I'm seeing is that, again, catalogs were one of the earliest sort of applications of metadata. Most catalogs that we know of today relied on the metadata coming from databases. Right? As a way to understand what are the tables, what are the queries, what are the popular queries, and so on. And then apply governance and other sort of capabilities on top of that. What is interesting now is that the variety of data systems is very broad. You do have streams of data, you have APIs, you have all sorts of events and so on. So if we think about data fabric as sort of that architectural layer that is capturing metadata and sort of trying to infer and create value out of it, I see that metadata as a feeder, or that data fabric as a feeder of metadata into catalogs. So one of the things that we've done, for example, is we have connected with most major catalogs out there that are commercially available or have API interfaces, and sort of opened that up and said, we can feed you metadata. What APIs do you have? And because as a lower layer system, because we have connectors and we do data integration and pipelining, we do see a lot of metadata. Do we infer a lot of metadata? So I think I'm also hoping for a more, not just collaboration among data users, but also collaboration among data vendors and providers, so that the information in one system can be made available to others. I know there's always a concern about competition, but practically speaking, people have tools in place. They've already spent money on maybe buying a certain product. Yeah. And if the next product they buy makes their existing product work better, I think it's a win-win for the end customer, who is ultimately more interested in creating the ultimate application. They want to deliver groceries to you, for example, and the data is sort of the necessity, the means to the end. Right?
Yeah. All right, here's, I think we can probably do one more question. And here's one, can the marketplace support federated data? Is federation a first-class concept of the product?
Yeah, I think this is for us to define. But if I think about data products, if they have the concept of access control, they have the concept of being a logical entity that can materialize in different places. It is possible to create a federation layer. I don't think federation comes sort of out of the box with it. But I think, especially, for example, we open up the APIs and we have seen people take our APIs and build their own tools and capabilities on top of it, including the first version of a private marketplace of data products was built by one of our customers by just taking off the shelf e-commerce components and plugging into API. So I would say that I think it should lend itself to that sort of a structure of being federated. Yeah.
Okay. Well,
yeah, I think there's one question that I did try to answer earlier, which is about large language models and generative AI. And what's your thought, Jay, on that? Like, we're all talking about generative AI and then how much of a game changer it can be. Where do you see this all coming together with data?
Yeah, so I remain in this state of amazed and frustrated, right? Amazed at what it can do and frustrated by how much stuff it makes up out of whole cloth, right? So, for it's one thing to use it as a tool to, sort of unblock your thinking, but would I trust a large language model, say for example, to infer metadata from a unstructured data source? It might give me a good start, but I don't think it's ready to be trusted as that's the final answer. It will be eventually. Yeah. I mean, we're very early days in this, and what we're seeing today, as amazing as it is just kind of scratching the surface. But I think using it for that kind of thing and for writing code, I think it's got a ways to go before it's much more than kind of like a design tool that you use at the beginning of the process, but then you've got to really refine it on your own down the road, further into the process. But I'm using it mostly as since my role now is mostly writing, I'm using it, for that, and I find it mostly not usable. I mean, it helps me think, but it doesn't produce anything that I can turn around and say, yeah, I agree with that. It's like more like, no, I don't agree with that. That's not what it is. It's this, right? But that helps your thought process. So.
Yeah, I think you're right on. We're in early stages of this. Today I saw a tweet by someone who took, its lab reports from the hospital and put that into, I think, a GPT model to explain like what's going on, and it created that sort of description in a human understandable way. And this person was quite impressed. And I was thinking that, even within the data ecosystem, we're always trying to understand what is the lineage of this data? Where does it come from? What is happening here? What is this pipeline doing? And I think as this technology matures, maybe it is able to take some of these disparate configurations across disparate systems and make sense of that and present to the user. I think the gotcha will be that it might even make up stuff. I mean, there's, there is that aspect of generative models where it's hallucinating. And and we might have to be careful about that, but I think it's promising.
Yeah, so, yeah it's very promising, but not quite done yet. All right, we're at the top of the hour, so I think it was a great discussion. Thanks, Saket, for inviting me, and everybody for attending and asking some great questions. Yep, I think we
Thank
can
you,
wrap
Chair.
it up.
I think this was an excellent conversation, and really appreciate the audience questions. And we are, I'm available on LinkedIn and easily accessible if anybody wants to reach out to me or to anybody at our company. But this is an exciting space, data fabric itself, generative AI, and I think there's a lot to come. There are many data challenges to solve, And I think this is a step in the right direction to help us get there.
Definitely. All right.
Okay.
Well, thank you, everyone, and have a great rest of your day. Bye.
Thank you.